Yes. Now in this class we will study about the principle of homogeneity. This one is the next point regarding application of dimensions. So this one is the third one. So in this third one, there is a principle of homogeneity. Actually, what is it? So basically, this one is the status of an any physical expression. Any physical expression that should be same. That means what? Now we can also understood this one by using an example. Just like you know that we have kinematical equations like s is equal to ut plus half at a square, v square is equal to u square plus 2as, like v is equal to u plus at and so on. So to use this principle of homogeneity, now here we are going to take an example. In example 1, just I am going to use kinematical first equation. So kinematical first equation is that v is equal to u plus at. Right now here we have to use or implement in this equation the principle of homogeneity. So accordingly your this physical expression that will be same. So that would be same dimensionally, right? So that should be same dimensionally. Dimensionally it should be same. That is what would be the dimension in left side of this expression, that will be same on right side also. So see, v is equal to u plus at. You know v is final velocity or final speed, whatever. So the dimension of speed or velocity, that is lt minus 1. It is dimensionally. Now you just write down dimension of initial speed, that is lt minus 1. And then you write down the dimension of acceleration lt minus 2, and this time its dimension be t. Now finally lt minus 1 in left side. What is on right? So on right side lt minus 1, and after doing calculation this one and this one be cancelled. So that would be also lt minus 1. So how much be there? lt minus 1 plus lt minus 1, that would be what? So dimensionally it is lt minus 1. So this one is lt minus 1 and dimensionally this one is also lt minus 1. So you are seeing here that dimensionally whatever on LHS, same on RHS. That means LHS is equal to RHS, and that is called your principle of homogeneity. Principle of homogeneity. Okay, I think in your mind one confusion be there, that how we have written this one. lt minus 1 plus lt minus 1 is equal to lt minus 1. So for this you have to use dimensions. So I am just briefing here about algebra of dimensions. According to this, one, number one, if someone want to add L plus L, someone want to add subtract L minus L. Third one is suppose divide L divided by L. This one is our dimensions. L with the dimension of length. And now number four, if you wanted to multiply L with L, so what would be there? So see, algebraically L plus L is if you wanted to write the algebra of arithmetic, so arithmetically it is L plus L with 2L, but dimensionally it is not L plus L, that is 2L, it is not. So how much will be L plus L be L? Similarly L minus L, arithmetically 0, but dimensionally this one is also L. Now L by L is 1. This one is arithmetically. That is algebra of arithmetic is like that. And this one is L into L. This one is L2. So you have to use this algebra, and this algebra is called algebra of dimensions. Algebra of dimensions. Right. So see here, LT plus 1 plus LT plus 1. That is L plus 1. L is L. So this one you can write down like L t minus 1. In same way, if you multiply anything with any dimension, suppose here is written by, suppose you want to write L plus 2L, so that would be not 3L, that would be also L. Accordingly, if you wanted to subtract 2L, L minus 2, you wanted to subtract L from 2L, so that would be also L, and like that. Okay. So this one is an example. Now here I want to take one more example. Example 2. And this one is if mathematical second equation, if I wanted to take. So your mathematical second equation is S is equal to ut plus half a t square. So that is how much. Now accordingly, you want to write S is equal to ut plus half a t square. So dimension of S, this one is distance, that is length. So this one is L. Initial speed is u, Lt minus 1, t with the time, that is t, plus half with the no dimensions. Acceleration Lt minus 2, and then time square, that is t2. And then finally this one is L. From here this one and this one will be cancelled, so L will be there. Now from here t2, t minus 2 will be cancelled, so there is a half L will be there. So what you are getting here, that L is equal to L. So this one is also dimensionally correct. So this is called principle of homogeneity. So hence proved this one is dimensionally correct. Dimensionally correct by using this one. Okay. Now one more example. Just take here example 3, and using mathematical third equation. So your mathematical third equation is v square is equal to u square plus 2as. So what will be there? You can see v square is equal to u square plus 2as. Now from here, this one is your final speed. So Lt minus 1, its square. Initial speed Lt minus 1, its square, plus 2, dimension of acceleration Lt minus 2, and dimension of distance, this one is L. So what you are getting here, L2 t minus 2 after being multiplication by its power. There is also L2t minus 2 after being multiplication with its power plus 2 be there. And now where is L is L2 and this one is still t minus 2. So what you're getting, there is a multiplication of 2, but according to principle of homogeneity you have to use, and now here there you will use that algebra of dimensions, that is dimensions of algebra. So accordingly what you will get here, that L2t minus 2, this one is equal to L2t minus 2. So this one is also dimensionally correct. This one is also dimensionally correct. And this is called principle of homogeneity. Okay. Next point is to check the correctness of an equation. So now point number 4, to check the correctness of the equation. So how we can check the correctness of the equation? If any equation that follow the principle of homogeneity, that means your equation be correct. So you can see here that if an equation, or if any equations that allow to follow the principle of homogeneity, that means your equation is dimensionally correct. And it is checked. Alright. So just take an example. In same manner, last time that you have taken, like the equations of kinematics. So here we will take some different equation. Just suppose there is a equation like equation of time period. Equation of time period. You know that equation of time period is equal to 2 pi under root L by G. You have to check that whether this equation is true or what. So if it follow the principle of homogeneity, that means your equation of time period will be correct. So you just say, you know the dimension of time period be t, because this one is time, very simple, and this one is 2 pi, no dimension be there. Dimension of L, because a root be there, so this one is length, so this one is L, replace root, power half, and G, acceleration due to gravity, its dimension, that is Lt minus 2, and there is a, because it is in denominator, so when it come in numerator, so there is a power minus 1. Now after doing calculation, t, this one is 2 pi, 2 pi be there because there is no dimension. Now from here you are seeing that l to the power half from here, and this one is minus half be there because a root be there also, so there is a minus half. So here is a minus half. After doing multiplication, there is also l to the power minus half is there, and minus minus plus t to the power 2 into half. Okay, so from here you are seeing that 2 and 2 will be cancelled, and l to the power minus half, there is plus half, so this one and this one will be also cancelled. So you, how much we getting? You getting t only. So here is t is equal to t. We have replaced this to 2 pi because 2 pi is constant. We are seeing that this one is constant, and constant having no dimension. But this one reflecting principle of homogeneity. This one is according to principle of homogeneity. Accordingly, so you can say that so accordingly you can check the correctness of any equation like that. Okay, so here we have taken one example. You can take any examples and that you can check. Let's suppose if you want to check any other example, that the equation of frequency. So you know that equation of frequency is 1 by 2L of root T by mu. So you can also check this one. So after doing calculation, dimensionally you will get its dimension is T raised, frequency is -1, and there is also T raised -1. So you will get this one. Alright.